Hey, my fabulous third graders. You have just finished the investigation of Franklin Zoo. And an investigation, remember, is a time when you're first being introduced to a concept. So if you don't know how to do the whole thing, do not worry about it. The point of an investigation is for you to take 15, 20 minutes and just work it out. I find that drawing pictures helps me when I'm trying to figure out what I should be doing, and you can solve it any way you can. And then we sometimes will have a Congress about it, but just this, and that would be a Zoom, but just this first time, I figured I would just make a video since this is our first time working together. So the Franklin Zoo was about some, let's see, I'll read it to you. The Franklin Zoo has some very special animals that attract lots of visitors. There's the twin apes, Barry and Grady. And then there's a set of chimpanzee triplets, Barry, Larry, and Jerry. So the story is that the zookeeper brought the twin apes a basket of their favorite fruits. Each basket contained the following, and then they gave us a list of a whole bunch of fruit. The first basket was filled with one grapefruit. So I guess they each get one, right? One way we could do is just draw a little G in a circle that would represent my grapefruits, right? And so there's two grapefruits. Since we're adding the same amount, one and then one again, that's a good time to use our multiplication. I could write 2 groups of 1 is 2. There's 2 grapefruits, right? The next was 2 peaches. So in each bag or basket, there was 2 peaches. There's my 2 peaches, and I might put a P in the middle. When I'm drawing for math, I'm drawing a model. I'm not having to draw and make it look like a real peach. But I do see there's 2 peaches, one group of 2 peaches and 2 groups of 2 peaches. So I could write 2 groups of 2 peaches is going to equal how many peaches altogether? 1, 2, 3, 4. 4 peaches. In the next basket, there's 3 oranges. So I might draw 3, and I could do any kind of model I want to as long as I can remember what it stands for. So now I have 1 group of 3, 2 groups of 3. So it'd be 2 groups of 3 equal 6. So I have 6 total oranges. The next one is going to be 4 apples. So I've got 4 apples in one of my groups and 4 apples in the second group. So that would be 2 groups of 4 apples is going to be 8 apples altogether. You're seeing a pattern, aren't you? Let's do 5 lemons. And I might decide to draw my lemons. Maybe I'll draw my lemons like that. 1 group of 5, 2 groups of 5. So 2 groups of 5 equals 10. And then the next one is 6 bananas. And I might just decide to do a 6 instead of drawing a model to represent my bananas. There's 1 group of 6 bananas, and there's another group of 6 bananas. That's perfectly fine too. So I have 2 groups of 6 bananas equals 12 bananas. And it goes on and on and on, all the way up to 10 blueberries in one, and 10 blueberries in the second one, and I've gone all the way down to the bottom of the list. And I'm seeing that I have 2 groups of 10 blueberries, and that would be 20 blueberries. And so as I'm seeing that each of these 2 animals are getting the same amount, I can see that I see my two timetable kind of showing up, and I'm looking at some patterns. Once I get this all written down, I'm going to then analyze it for patterns. I see that each and every time there's 2 groups, 2 groups, 2 groups, 2 groups, 2 groups, 2 groups, 2 groups. And then I notice that there's 1 in each group, and then there's 2 in each group, 3 in each group, 4 in each group, and so on. And I'm also noticing that there's a pattern 2, 4, 6, 8, 0, and then a 2, 4, 6, 8. You'll see patterns in the multiples. These are called the multiples of 2, the answer you get when you multiply 2 by another factor. So once you get your information written down in your investigation, and yours might look totally different than mine. This is just one way that students do it sometimes. You want to look for patterns, look for anything you might learn from the information that you wrote down. Well, in the next part, there's not just 2 animals, there's 3 little chimpanzees. Barry, what were their names? Barry, Larry, and Jerry. Barry, Larry, and I don't want to forget who they are, so I might label it somehow, even if I just label it with a letter. That helps me stay clear. So this time when they brought the grapefruits in, there was going to be a grapefruit for each one. And I can see now that I have 3 groups of 1 grapefruit. So 3 groups of 1 grapefruit is going to end up being 3 grapefruits, isn't it? Well, then how about, I'm going to skip down to 4 apples. There's 4 apples for Barry, 4 apples for Larry, and 4 apples for Jerry. So what I'm seeing is I have 3 groups, 1 group, 2 groups, 3 groups of 4 in a group. How many is that going to be total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 6. That's 8, 9, 10, 11, 12. So there's 12 apples altogether. So as you continue to feed the chimpanzees their fruit, you probably noticed that you were adding 3 groups of the same number each time. So let's go to bananas, the 6 bananas, 6 bananas, 6 bananas. Now, if you're not used to counting up 6 bananas, you may want to do pictures 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are my 3 groups of 6 bananas. So 3 groups of 6 bananas equals how many bananas total? If you counted up all 3 groups. 18. 18 bananas all together. So we had a little practice multiplying with 2s. We had a little practice multiplying with 3 groups of the same number. And when we multiply, we like say where there was 3 groups of 5, and that was when you had 5 lemons. 3 groups of 5 lemons would be 15 lemons altogether. Let's remember that the 2 numbers that we multiply, one number is going to tell us how many groups we have. One factor is what it's called. And the other factor is going to tell us how many are in each group. Each of the groups that we're adding, right? So it was 5 lemons once, 5 lemons twice, 5 lemons 3 times. 3 groups with 5 in a group equals a total of 15 lemons. That's our 3s. And we'll be doing a lot more with that. Let's take that same amount, 3 groups of 5 equals 15. So let's say we have our 15 lemons, okay? And we'll imagine there's a big basket of 15 lemons. And this time, what if we took the lemons and we divided it among all 3 of the chimpanzees? So I had this much all together, and there's Barry, there's Larry, and there's Jerry. I want to take this 15 and divide it among all 3 of them. How many would each one of them get? Let's see, I have 15, and I'm dividing it among 3 groups. There's my 1, 2, 3 groups. How many will be in each group? Well, was there one of these numbers up here that told me how many were in a group just when I was multiplying? 3 groups with 5 in a group equals 15. Which one of these numbers told me how many were in each group? Right, it's the 5. 5 in each group. So now I can know that 15 divided among 3 is going to end up being 5 in each group. And I'm using my knowledge of fact families to help me along with that, right? Also understanding that one factor tells us how many groups we have and the other tells us how many are in a group will help us as we're dividing out as well. We'll do one more of these. Let's do the one where there was 24 strawberries. This is on your investigation. 24 strawberries divided among those 3 chimpanzees. How many is each one going to get? So I have 24. Let's pretend I put them in a big basket, and I'm going to be giving them out to the 3 chimpanzees. How many would each get? Well, 24 divided by 3. 3 times what? What number do I have to have 3 times in order to get to 24? If I don't know, I can go ahead and divide them out like this. I can give 1 to this guy, 2, 3. I've gotten rid of 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Let's see how many is in each group. Let's see, 3, 6, 7, 8. So the answer would be 8 in a group. So we have a total amount, we have a number of groups, and we have how many are in each group. That should, I wonder if you're going to fill in a multiplication sentence that matches this or is in the same fact family as that. What would you do? We know we have 3 groups. How many in each group? 8. Would give us a total of 24. I notice that when I'm multiplying, my biggest number is the product or the answer. And I notice when I'm dividing, the biggest number is the amount I start with. And that's a good thing to notice. Well, the next thing we're going to do is a quick, you're going to have a little assignment that you're going to do. I'm going to tell you a story, and you're going to use your little counters and your hundredths chart to help you along with this story. So the story is about a boy named Johnny who loves Triceratops. That's his favorite animal. And one night he has a dream, and he's counting how many horns were there, since it was one Triceratops and there was just 3. Well, the next night he has a dream about 2 Triceratops, and he was trying to count out how many horns that would be if there was 2 Triceratops together. And that would be 2 groups of 3. And then the next night he had a dream, and there was 3 Triceratops in his dream. And he was trying to keep track of how many horns there were in the dream each time. And then the 4th night, he had a dream that 4 Triceratops were there, and he was trying to keep track of how many horns that would be. Well, he goes all the way up to 10 nights of dreaming about Triceratops. So what you're going to be doing is you're going to be using your marshmallows or corn kernels or macaroni, whatever you're using to count out. You should have 30 counters, and you're going to kind of portion out how many horns for the Triceratops there were each night, each of the 10 nights. Now, once I find out, I know the first night was 3, right? You're going to color in 3 in your hundredths chart. On the second night, you'll probably take your little counters. There's the first night. The second night, how many are there going to be? 6. So you count, you color 6 in your hundredths chart. The third night, count them out. You can push over 3 more. How many horns will there be the third night? I'm gonna let you finish that. So go all the way up to 10 nights. And remember, there's 3 additions. There's first night, there's 1. The second night, there'd be 2. He has this one the first night. Then he has this one and another one the second night. The third night, he'd have 1, 2, 3. So he keeps getting more in his dream every night, okay? The same number, the number of what night it is the same amount of Triceratops that are in his dream. So go ahead and use your counters and your hundredths chart to keep track of the horns on the Triceratops. And then once you get it filled in, I want you to analyze. That means look closely and look for patterns on your hundredths chart and see what you can find out about the numbers that you discover.